Okay, now we're going to talk about your exponential function. So the formula that we generally use for an exponential function is going to be dt is equal to a e some constant with respect to time plus b. Now, when we're graphing these sorts of things, especially because we're talking about displacement, velocity, and acceleration, this variable along the bottom here is always going to be t, which means that this side up here is going to be dt, or your displacement with respect to time. Now, the coordinates I've picked for this are going to be 0, 0, which is the start coordinate, and this one up here should be your end coordinate. Now, you've been given the chance to pick any time within 15 minutes of the person that you choose to win. So let's say that my physical data finished at 2 hours. Okay, that means that my person can finish 15 minutes before or after, depending on who you want to win. It doesn't have to go up to the full 15 minutes. It doesn't have to be 2 hours and 15 minutes. I could go 2 hours and 1 minute or second, whatever you want. It's up to you. Just have to keep it within that half an hour block between the two. So this is your end coordinate. Now, next thing we're going to talk about is what b does to the function. So in this equation, b is our constant value on the end. If I choose for b to fall above the line, it's going to give this shape to the graph. Now, you'll have to look up how you describe that shape of the graph. Okay, is it convex, concave, whatever? There's a technical term for it. So describe the shape of this curve. If it's above, it looks like that. If it's going to be an asymptote that's below, it's going to look like this. Now, when you're writing your report, I would justify as to which one you think is more accurate and why. The other effect of b I want to talk about is if I have b very close to these coordinates, like I've got in this example here, I've got 13 and -1, which means it's only one away in either direction to where my last coordinate is. That's going to affect the dilation of this. The further away b is from my coordinates, the more chance it has to form a more straight form. Now, it doesn't overly matter because this is a separate person altogether. So either you're saying that this person was increasing the whole time, or actually they're both increasing, but one of these has a steeper slope, which means that they're increasing in speed faster than the other one. You know, you could argue reasons for or against. Maybe you're getting tired at the end of the race and that's something you want to preempt. Okay, so let's develop the function. Now, the first one we're going to look at is developing this kind of function. So we're going to let p be any number other than 0, which means in this case I'm selecting it to be -1. Now I'm going to substitute that value in to my function so that I can see what this looks like. So dt, ae, kt, and -1. Now I'm going to let dt equal, now I'm going to choose 0, 0 first because it's just going to make my life easier. So I'm going to let that equal 0 and I'm going to let t equal 0 and substitute them into this formula here that I'm developing. So a, e, k, 0 minus 1 is equal to 0. Now, this section here, anything to the power of 0 is always 0, so I'm just left with a times 1 makes a, -1 is still on the end, and this is still equal to 0. Last thing I need to do here is grab that constant, move it to the other side, and I'm left with a equals 1. So now I can say that my formula for this equation is going to be dt is equal to, now I don't have to write the 1. If it was a different number, I would write it, ekt minus 1. Now I'm going to use the other coordinate to help me work out what value, if I can ever figure out how to scroll down on the page. Nope, that's not it. Okay, we'll just do it over here. So Now I'm going to use the other coordinate to help me work out what that value of k is. So this coordinate here, I'm going to let t equal 10 when dt, or the displacement, is equal to 12. So, where are we? Here. 12 is equal to e k 10 minus 1. Move the 1 to the other side to make it 13 ek 10. Now, when I move the e to the other side, because it was an exponential function, the opposite of that is a logarithmic function with the base of e. We also refer to that as natural log. So now I've got ln 13 is equal to 10k. To get 10 on it, k on its own, to take that across by dividing, and I'll be left with k is equal to ln 13 over 10. Now you can get that as a decimal, but you know that every time that you get something as a decimal, it rounds it and you lose some information. So in this case, I'm going to keep this the same in my formula. Maybe that's something you'd like to justify in your assignment. Who knows? Up to you. Okay, so now my last step is to state the equation that I have calculated. So dt is equal to e ln 13 divided by 10 t minus 1. Okay. Now, if you chose to do the other style of function, it's going to be a very similar process, but your answer might work, or your algebra might be a little bit different because you'll have that value in front. But I've got faith in you. I believe you. You can do it.